this is a continuation of the differentiation rules. I just did not finish the examples because I didn't want your video over the weekend to be too long. So we're going to just do a couple more examples using the same thing. So if you want to not make a new title, you can just add this to your notes before. You can do that. Or you can say, like, differentiation rules continued. However you want to say it is fine. But all we're doing basically is just a few more examples. So here, we're going to find the points. On y equals x to the fourth minus 6x squared plus 4. So find the points on that line where there is a horizontal tangent. Say that one more time. Kind of. Yeah, horizontal tangent. So we know that a tangent line is the line that hits the curve at a specific point, and so they're saying find the points where the tangent line happens to be horizontal. And what is the slope of a horizontal line? 0. So when we say we want a horizontal tangent, that means we're looking to see where m equals 0. We want a 0 slope there. So for us to be able to find the equation that will give us any of the slopes, we have to find the derivative. How do we find the derivative using our shortcuts? 4x to the third, good. To the 1. And then plus 0, we don't even have to write it. Okay, so if you want to write it down, this is the formula that you're going to use to find any slope at any point. Okay, so this right here is the equation. I can plug in any point, any x value that happens to be true for this polynomial, and it will always tell me the slope at that point. All right? Okay, so these x's stand for the x coordinates that we're going to use in the original function. Y prime actually is not talking about a y coordinate, it's actually talking about a slope. It's talking about what the slope is at that x coordinate. So I know that I want a horizontal tangent, so what do I need to set y prime equal to? 0. We want to find the horizontal tangent, so we're going to say 0 equals 4x to the third minus 12x. And then do we know how to solve that? Not plugging in the calculator. You can solve it by hand. It's not too bad. Factor. Factor out an x and a 4. So 4x on the outside, and then what's left over? Okay. What does the part that's in parentheses look like to you? It looks like difference of squares, except 3 is not a good number for that, right? But we can still do difference of squares. So I'm going to go ahead and keep this 4x in the front. And then I'm going to set it up for difference of squares. 1 parenthesis with the plus, 1 parenthesis with the minus. And what should I put first? X. And then what would you normally do for the second part? You put the square root of that number, right? I'm going to go ahead and put square root 3. Right? Because square root 3 is the square root of 3. Okay. So I still did difference of squares. It's not a perfect square, but I was able to make it work. Right? Okay. So what does this x equal right here? 0. What does this x equal? Negative square root 3. And then what does that x equal? Positive square root 3. So it looks like if we were to graph this, and we're going to do that in a second so you guys can see how this worked. But if we're going to graph this, it means that in these 3 x values, that's where we see the graph have a maximum or a minimum, right? Because that's how horizontal tangent lines happen, is they happen at maximums or minimums where you've got a slope of 0, where you switch directions from positive to negative. All right, so if I wanted to find the y coordinate of the point, like because it says find the point of that original function where there happens to be a horizontal tangent, am I going to plug this x back into this equation, or am I going to plug the x back into this equation to find the y-coordinate? The first one, right? Because y here doesn't mean y. What does the y here actually mean? It means the slope. It means whatever slope at the x value. Okay, so we're going to say y, if I plug in 0, is going to be 0 to the 4th minus 6 times 0 squared plus 4. And what would you get? 4, okay. And then we're also going to plug in negative square root 3 to the 4th minus 6 times negative square root 3 squared plus 4. And let's try doing this one without a calculator. See if you can handle this one. That's rough, right? You can totally do this. So negative root 3 to the 4th means that you're going to have a negative root 3 times a negative root 3. What does that give you? Positive 3. And then you're going to have another negative root 3 and another negative root 3, which also gives you 3. And you're going to multiply those together. 9. So negative root 3 to the 4th is actually 9. Negative 6, what is negative root 3 squared? 3. So negative 6 times positive 3, negative 18. And we got that plus 4 on the end. Okay, so 5, is that what we decided? Negative 5, okay. So our first point is the point 0, 4. Our second point is the point negative root 3, 5. And then we'll go ahead and find our other point. And what's going to happen here as well? It's going to be the same. It's still going to be negative 5. Okay, if you have a calculator on you, go ahead and grab it, and we'll see if this answer makes sense or not. So I'm going to go ahead and plug in that original function. Can you guys see, if you look at this picture, how it has the horizontal tangent line at those 3 points? Negative root 3, positive root 3, and 0. And if you want to make your calculator look at it, you can hit second trace and option number 1 for value and just plug in those x values and see where it's telling you that that is on the graph. So there's negative root 3 down there. Yep, horizontal tangent line makes sense. 0 is right up there. Yep, that makes sense. And then square root of 3. Yep, that makes sense. So, hey guys, listen carefully. One of the things that's nice about this type of math is that even though we're doing all of this by hand, if you get an answer where you say, oh, the slope should be 9, if you graph that original problem, a slope of 9 should make sense at that point, right? When we look at this graph, a slope of 0 makes sense. There's a certain point where common sense can help you to check your answers to the problems. Like, you don't have to do a lot of math to check your answer here. You just plug it in and go like, yeah, that makes sense. A horizontal tangent line of 0, slope 0, totally makes sense. Okay, we're going to do another example. Are you ready? Aren't these fun? No? They are difficult, I agree with you. All right, find an equation of the tangent line to y equals 1 plus x squared over the square root of x when x equals 1. Now, a tangent line is always a straight is touching a curve at one point. So what are the two pieces of information you need to write the equation of a straight line? What are the two pieces? You need the slope, and you need, not necessarily the y-intercept, but what is the y-intercept? It's like a point on the graph, right? Okay, so we don't necessarily have to have the y-intercept, but we do have to have a point. Okay, so we know that our goal is going to be to have a point. We want to figure out what a point is, and we want to figure out what the slope is. Okay, the point part is pretty easy. How do we find the point? You can just plug it in, right? So to find the point, I'm going to say 1 plus 1 squared divided by the square root of 1. So that's 2 divided by 1. So our point is 1, 2. So we got that. So how do we find the slope of a tangent line? We want to find the derivative, right? And we can go ahead and just find the general equation for the derivative, and then we can just plug 1 in, and that will tell us specifically the slope at 1. Okay? So I want to find y prime, basically. This is me. I need to find y prime. And I'm going to show you real quick. I tried, remember in the notes how I said there's the quotient rule, and it's like low d high minus high d low divided by the top 1 squared, however that fits into that. I tried to do the problem that way, and it got real terrible real fast. So we're not going to do that. And this is the thing about calculus, is that you don't always have one approach to the same answer. Sometimes there are a couple different ways to do it, and one of them is easier. So I started off, I was like, yep, that's a quotient. I'm going to do the quotient rule. I got partway through it, and I was like, holy cow, this is really messy. Are you guys seeing all these exponents and terribleness? Yes. Okay. So what we're going to do instead is we're going to take this, we're going to split it apart. So I'm going to have 1 over root x and x squared over root x. Does that make sense? So I'm kind of unadding them together. I'm going to think of it as two fractions. Go ahead and erase the prime if you wrote y prime. We shouldn't have that yet. So I'm going to say 1 over square root x plus x squared over square root x. So it's kind of like they had a common denominator and they put the two fractions together. And I'm going to go ahead and separate the two fractions and separate them back out. So this is me just making the original equation one that's going to be easier for me to work with. And that's because I already tried the quotient rule and it was terrible. I didn't want to do it. What is the exponent on this x right here? It's 1/2, right? Anytime you have a square root sign, that's an exponent to the 1/2. And if it's on the bottom of the fraction, what does that mean? It's negative. Okay, so I'm going to rewrite this as x to the negative 1/2. At this point, do you feel a little bit more comfortable about finding the derivative of that piece? Yeah, we know how to find those pretty easily. All right, and then on this one, I'm going to say I've got x to the second, and then I've got x to the 1/2 on the bottom. And what do you do with the exponents if you have an exponent on the top and the bottom? You subtract them, right? You guys have done that before? So this is kind of like 2 subtract off an exponent of 1/2. So what's 2 minus 1/2? It's 1.5. Are you guys okay with me saying that that's 3/2? 1.5 is the same as 3/2. So it was x to the second, and then the bottom was x to the 1/2. Oh, the next step, you're talking about the derivative. I haven't done the derivative yet. Okay, so at this point, this is a fairly easy derivative for us to guess. We don't like the fractions necessarily, but now we can use like the more simple steps. So I'll go ahead and say y prime. And what should I do for the first part? Negative 1/2 x. If you have negative 1/2 and you subtract 1 from it, negative 3/2, right? You had negative 1/2 and you subtracted a whole 1 from it. It is ugly, but it's not as ugly. Remember what I had? It's not as ugly as that, right? All right, and then what do we do here? Move the 3/2 to the front. x to the 1/2. Okay. Now, it is possible to do a lot of simplifying here, but do we need to simplify if all we want to know is the slope? No, we don't need to simplify. So at this point, what should we do? We have to find the specific slope at 1. So what should we do? Plug in 1. Does that make sense? Yeah.
I don't understand why
I can't add these together because they have different exponents. It'd be like trying to add x squared and x to the 4th together. No. That's x squared times x to the 4th.
Okay.
So when you can multiply any exponent you want, but when you add, they have to have the same exponent. Yeah. All right. So at this point, this is my formula where I can find the slope at any point, right? I could plug in 5 and find the slope at 5. I could plug in 17 and find the slope at 17. I could plug in any number I want and find the slope anywhere. I want to find the slope at 1, so I'm going to go ahead and plug in 1. So I'm going to get negative 1/2 times 1 to the negative 3/2 plus 3/2 times 1 to the 1/2. And the nice thing about them having us plug in 1 is that it doesn't matter what exponent you raise a 1 to, it's always 1. Right? So 1 to the negative 3/2 is still just 1, and 1 to the 1/2 is still just 1. So what do I get here if I simplify it? Yeah, you get negative 1/2 plus, what do I get over here? 3/2. Okay, so negative 1/2 plus positive 3/2 is 1. So we got a slope of 1. That's what we ended up finding. So I'm going to go ahead back up here and I'm going to put that I have a slope of 1. And in calculus, what form do we use so that we can be lazy? We use the point slope form. So how should I write point slope form for this? Y minus 2 equals 1. So that is the equation of the tangent line. Okay, let's go ahead and check that answer, because it should show up, right? If we did it right, it should show up. So let's go ahead and take our calculators. For y1, I'm going to go ahead and graph the original function. And then for y2, I'm going to get my y alone just by adding 2 to the other side. And I'm going to go ahead and graph these at the same time. All right, does it look like it's a tangent line at x equals 1? Yep, so that fits. X equals 1 is right about in there, and that's a tangent line to it, so we know our answers make sense. So your calculator may not be able to find the derivative for you, but your calculator, if you think about what you're doing, can help you check answers pretty well. Okay, we're going to do one last example that's kind of a story problem, because those are kind of good to be able to do. And then I will let you practice finding these by hand. Aw, so fun. All right, at time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. Because the initial velocity of the diver is 16 feet per second. The position of the diver is S of t equals negative 16t squared plus 16t plus 32. And here we're going to say S is meters, T is seconds. If you want to shorthand any of that when you write it down, that's totally fine. All right, our first question is, when does the diver hit the water? All right, when does the diver hit the water? All right, so S of t, it says that he's 32 feet above the water. That's what the 32 comes from. Are we listening? And the initial velocity is 16. That's what this 16 comes from. Does anyone know what the negative 16 in the front is? Gravity. It's gravity. All right, so when does the diver hit the water? So that means we're solving for t. And what does that mean about S of t? How far away is he from the water if he hits the water? 0. So we're going to say 0 is negative 16t squared plus 16t plus 32. And this is a reasonable quadratic to solve by hand. Why would I say that? You can divide by 16, and that's nice. That'll fix the problem. And I'll go ahead and divide out the negative 16. So that gives us t squared minus t minus 2. And what do we get when we factor that? T minus 2. T plus 1. So at what time is the diver hitting the water? We've got two solutions, right? We got to check them. So t equals 2, so at 2 seconds, and then what's the other solution? Negative 1. Does negative 1 make sense? No, that's an extraneous answer. Okay, so the diver hits the water after 2 seconds. The second question we want to ask, and this is the end of our notes. Woohoo! The second question we want to ask is, what is the diver's velocity at impact? Okay, we're going to think about this. So what is the diver's velocity at impact? That's an as, not at. At when they're asking about velocity, what does velocity mean? Speed, right? It's like how fast you're going. Would it be fair to say that if the diver's like hitting the water, that velocity is the rate of change that he's doing? Right? It's the rate of change. And we're talking about the rate of change at that instant. This is an instantaneous rate of change. So what do we need to find the velocity? the slope, which is the derivative. We need to find the derivative. So if you have the position of something, then the velocity is the derivative of the position, and that's because velocity is a rate of change. Does that make sense? It's a rate of change. So we're going to say the velocity, v of t, is the same thing as the derivative of s of t. All right? And you will see this a lot. This is something that you'll be expected to remember, that you take the position that it was in and you take the derivative of that, and that's the same thing as the velocity. Okay? All right, so now we want to go ahead and find v of t. So if we look back at the original function, it was negative 16t squared plus 16t plus 32. So let's go ahead and write it as a velocity now. What should we have if we're taking the derivative? Negative 32t plus 16, right? So we're taking the derivative. Okay. And we're saying what is the velocity at impact. So this is the formula that's going to tell us the velocity at any time. And we want to know what happens at impact. So what do we plug in? 2. Plug in 2. So 0 is how far you are from the water, but 2 seconds is what allowed that to happen. At 2 seconds, that's when we got it. So now we're going to find v of 2. And what should we get? That's negative 64 plus 16. So negative 48. And then what are the units on this? The rate of change. Meters per second. Does a negative answer make sense for this? Does it make sense? He's going down. So velocity is not just, speed is the one that's kind of like an absolute value, like you can't go negative 5 miles per hour. But velocity is talking about direction as well, and the direction is down. So a velocity that's negative kind of makes sense because you're going down. Okay. So his velocity at impact is negative 48 meters per second. Whew.